The moon is the only other world humans have ever stepped upon, yet no person has visited its surface in over 50 years. It is located approximately 238,000 miles from Earth. In the context of the solar system, this is a negligible distance. It takes light only 1.3 seconds to travel between the two bodies. For the Apollo astronauts of the 1960s and 70s, the journey took roughly 3 days. Despite this proximity, the moon remains a desolate landscape of gray basalt and regolith. It is a world that was reached, explored briefly, and then effectively abandoned by human presence. Understanding why this happened requires looking at the moon not as a destination, but as a hostile environment that dictates the limits of human biology and technology. Scientists and space agencies, including NASA and its international partners, view the moon as a critical data set for the history of the solar system. Because the moon has no atmosphere and no liquid water, it does not experience the erosion that constant weather provides on Earth. Its surface is a preserved record of billions of years of cosmic history. Every crater is a fossilized memory of an asteroid impact. By studying these impacts, researchers can determine the frequency of collisions in the inner solar system. This helps calculate the risk of similar impacts hitting Earth. The moon also serves as a laboratory for understanding how prolonged exposure to solar radiation affects materials and biological life. The decision to stop sending humans to the lunar surface was not based on a lack of scientific interest. It was a result of the extreme difficulty of maintaining a presence in a vacuum. To understand the transition from exploration to abandonment, one must look at the specific physical requirements of staying on the moon. The first challenge of any lunar mission is the lack of an atmosphere. On Earth, the weight of the air provides pressure that keeps our internal fluids in a liquid state. Without this pressure, the boiling point of liquids drops significantly. On the moon, a human cannot survive for even a few seconds without a pressurized suit. Oxygen must be brought from Earth or extracted from lunar rocks through complex chemical processing. Because there is no air to scatter sunlight, the shadows on the moon are pitch black. There is no dawn or dusk. The transition from day to night is instantaneous and absolute. Temperature management is the next hurdle. Without an atmosphere to insulate the surface, the moon experiences thermal extremes. In areas of direct sunlight, the temperature can rise to 250 degrees Fahrenheit. In the shadows, or during the lunar night, it can drop to minus 280 degrees Fahrenheit. A lunar day lasts about 14 Earth days, followed by 14 Earth days of darkness. Any technology left on the surface must be able to survive 2 weeks of searing heat and 2 weeks of deep freeze conditions. Most batteries and electronics designed for Earth fail under these stresses. Then there is the issue of lunar dust, known as regolith. Unlike sand on an earthly beach, which is smoothed by wind and water, lunar dust is sharp and abrasive. It is created by millions of years of micrometeorite impacts that shatter lunar rock into tiny, jagged shards. This dust clings to everything due to static electricity. During the Apollo missions, it clogged joints in spacesuits, scratched camera lenses, and caused lunar hay fever when astronauts breathed in particles that hitched a ride into the lunar module. It is one of the primary mechanical obstacles to a long-term human presence. The physical effects of lower gravity also present long-term consequences. The moon has only 1/6 of Earth's gravity. While this makes moving heavy objects easier, it causes the human body to change. Without the constant resistance of Earth's gravity, bones lose density and muscles begin to atrophy. Scientists are still determining if a human could live in 1/6 gravity for years without permanent skeletal damage. We know from stays on the International Space Station that microgravity causes vision changes and fluid shifts in the brain. Whether these same issues occur on the moon is a question that remains largely theoretical. Beyond the physical environment, the logistics of the journey created a natural stopping point for the first era of exploration. To get to the moon, a rocket must reach escape velocity, which is about 25,000 miles per hour. This requires an immense amount of fuel. Most of a rocket's mass is simply the propellant needed to lift the rest of the propellant into orbit. Once the initial goal of proving the technology was achieved, the high cost and high risk of these missions became harder to justify. The moon was no longer a place of mystery to be reached, but a resource-heavy destination that offered no immediate economic return. There are several myths regarding why humans have not returned. Some suggest that the moon is too dangerous due to alien presence, or that the original landings were not real. These claims are not supported by evidence. High-resolution imagery from the Lunar Reconnaissance Orbiter clearly shows the landing sites, the rover tracks, and the equipment left behind. The reality is more mundane. The moon is a difficult place to work. It is not abandoned because of a secret threat, but because the cost of life support outweighs the current technological capacity to sustain it easily. We also know what would not happen in a lunar environment. For instance, the moon will not drift away from Earth in a human time frame. While it is moving away at a rate of about 1.5 inches per year, it will remain our constant companion for billions of years. It will also not lose its dark side. The moon is tidally locked, meaning the same side always faces Earth, but every part of the moon receives sunlight at some point during its month-long rotation. In the current era, the perspective on the moon is shifting. It is being viewed as a potential service station for the rest of the solar system. Because the moon has lower gravity, it is much easier to launch a rocket from the lunar surface than from Earth. If humans can find water ice in the permanently shadowed craters at the lunar poles, that ice can be broken down into hydrogen and oxygen. This provides both breathable air and rocket fuel. In this scenario, the moon becomes a launch pad for Mars and beyond. It is no longer a destination, but a stepping stone. The 3-day journey to the moon represents the shortest bridge between Earth and the rest of the universe. For 50 years, that bridge has been empty. The footprints left in the 1970s remain undisturbed as there is no wind to sweep them away. The moon remains a silent witness to the early achievements of spaceflight. It sits in the sky as a reminder that the ability to reach another world is not the same as the ability to live there. The abandonment of the moon was not an end to the story, but a pause in a much longer narrative of how a species adapts to environments it was never meant to inhabit. Whether humans return to stay depends not on the distance in miles, but on the progress of the technology required to turn a hostile vacuum into a home. For now, the moon remains the closest world we have ever known and the farthest we have ever walked away from.